Hi, we're here at the I-74 bridge in the Quad Cities. We are on the new bridge right now that connects Illinois to Iowa. It would be Moline, Illinois to Bettendorf, Iowa. The new bridge is replacing the old existing I-74 bridge behind me. This is the main corridor for the Quad Cities. It has been roughly 4 decades in planning and preparation for this project. The project began in 2017 at the ISC Steel Mill in Gary, Indiana, fabricating the arches behind us. And the last piece was set roughly mid-2021, and the final roadway was completed earlier this year. So this is a new landmark for the Quad Cities. This was basically the main trunk line for all traffic and commerce coming through the area. The final keystone was set in early 2021, with the full roadway being completed in 2022. At this time, it is completely open to public traffic and the bike path, and it has been a major success for the community.
Like every Aldridge job, pre-planning starts right after the bid is won. For this project, there was a lot of prefabrication and pre-planning with all our subject matter experts and our field team along with the PM team. As you can see here on the bridge, you can walk inside of that arch, and all of the ITS systems and structural health monitoring systems were all pre-planned, pre-laid out, and installed in Gary, Indiana. So all the work was done on the ground. All of our material was installed into the arch, and then when it was lifted into place, we made our final connections. Another thing that was big for our pre-planning and pre-fabrication team were all the suspended conduit racks on this project, along with our subject matter experts laying out all of the racks and junction boxes. Prefab built all of our racks in the shop and shipped them out, and we actually laid them all on the catwalks before the bridge was decked and poured. So when our crew showed up to the location, all the material was on site. There was no double handling and shipping onto barges and getting out onto site with lifts. Next, Chris is going to go through some of the installation methods and a lot of the risk we had to account for on this project.
We're out here at the I-74 bridge. I'm going to talk about some of the scopes of work we've had. This is the bottom side of the bridge. We've done 5 different kinds of lighting, from navigational, aesthetic, street lighting, bike path lighting, and also we did some lighting around the outlook for the benches and the Oculus glass. Other things we've done out here too are the ITS systems, the trapeze system that goes all the way from Moline, Illinois to Bettendorf, Iowa. Roughly, I think with all the different scopes of work, we're close to 100,000 feet of conduit underneath the deck, on top, and also inside the arches. We've done ITS systems, SHM, and which is structural health monitoring system. We have corrosion sensors in the pavement we've done the vibration. strand cells, stuff like that with our subcontractors. We were able to pull out the inserts and use the trapeze that we had pre-assembled by prefab. And we also had that strategically planned with our general contractor Lunda to put in beforehand. Before the deck was laid with the wood, we were able to spot all the pipe, all the trapeze, all the ITS racks that were pre-made. We were able to set them down in the little bump outs and bolt them in place. Then we'll come back later on and then we do the wiring and every configuration and pull wire. Everything was laid out through our Agile with Tommy Howerhand, and we're also able to just make it, when we're able to work on the water with high winds, icing or whatever, we're able to go up to the catwalk system accessed by a JLG lift, and we're able to do all the work up there to keep the ball rolling, to keep the team going. So a lot of it was, we could always be versatile, bounce back and forth between the scopes of work to always keep it going. Let me talk about some of the risks and the kind of the obstacles that we had to overcome to get to the work. It wasn't just like a normal highway job where you could just drive up to the light pole controller, pull a wire from a handhole, nothing like that. A lot of it had to do with weather. We had inclement weather, we had a lot of wind problems, we had a lot of icing, damming. So a lot of our work was done underneath the arch span. The 800-foot arch span was done with barges and JLG lifts. And of course it happened to be right in the middle of winter time. But other obstacles, every day you take a boat out to your job. There's not too many times you have to do that. But so there was a lot of planning strategically through the general contractor and ourselves. We put up about 550 aesthetic lights total between the Paramount lights and the up lights for the arch for color changing. On the color changing lights, we had a lighting designer come in, give us different degrees, different angles of how to aim the lights. We did it all at nighttime work off of barges and lifts supplied by the general contractor and tugboats. So a lot of it was kind of a different scope of work for myself and a lot of the workers that we had. I'm going to go over the tasks and the scope of work that we did inside the arches. A lot of it was already laid out through our Agile system. We pinpointed our penetrations, our locations of everything. Everything was drilled for us inside the steel mill, so it was easy for us to go in and just do our work. Inside there, we did anything from ventilation systems to lighting systems to the electrical system. We had a high voltage side, a low voltage side. We had SHM and also ITS in there also. We did all that work out in Gary, Indiana at the ISC steel mill. We did 90% of it out there. The other 10% we did here on site. A lot of it was done with the Agile and also prefab. They did all the bends, the boxes, stuff like that. So when we put it together, when we get it assembled out on site, that we were able to just go in there, make the connections, pull the wire, and do the terminations.
So I'll touch on some lessons learned from the project. So my biggest takeaway for the job was the importance of pre-job planning. We were able to basically flush out almost every design issue before being on site. We had roughly 120 RFIs written, submitted before most of the work even started. Utilizing the extra time we were given when the job was delayed initially up front, we were able to basically detail out every scope, whether it was suspended below the deck, embedded in the deck or the barrier walls, or systems running through the arch. We had our SHME, Tom Howerhand, basically draft out in CAD every single working drawing for every single scope on the project. So we had those in hand before starting any operation on the job. In doing so, as Chris touched on briefly, we were able to give our steel penetrations for the arches to ISC. They drilled roughly 10,000 holes for us throughout both arches and basically alleviated Aldridge from any sort of field joint or steel drilling at all, which is a major, major pickup on the project. In the presentation, we'll go through each section of the bridge. Each section of the bridge had all the conduit detailed out for each different duct package, every different bend, orientation. Everything was detailed up front, every section of the bridge, and the specific conduit pattern had a number or letter assigned to it. So when the crew showed up on site, they had every single rack for every single insert that was precast in the bridge deck by Lunda, and we were able to basically turn those over to our foreman, and they were able to work off the working drawings, the entire bridge from start to finish.